We gotta make sure we finish up notes here today. All right, hey, all right, I'm gonna do this really quick because I know you're gonna need time to work on that worksheet. Worksheet's due tomorrow. If you guys want to talk, I'm gonna kick you out of this room because I don't care to hear it. Okay, so graphing today. We need to talk about those individual graphs. I gave you problems yesterday. I gave you problems yesterday that are factorable. Okay, so what I mean by that, I was giving you problems that you can actually factor apart. You can actually figure out the real answer to it. Like for instance, if I factor out these, so if I do this by grouping, these are problems like you did yesterday. This actually might look like one of yours. You had to factor out x squared, so that's x plus 8. If I factor out a -4 back here, that's x plus 8.
Where's your pencil sharpener?
Guest starring Jim Chris.
Okay. So I factored out, now this point, this can factor even further because you notice that they both have x plus 8s. And now this can go further because the difference of squares. So the reason why I bring this up is because I know that on those problems I asked you to graph. Just do a light graph, kind of see where it's going. On this particular problem, I'd be hitting 3 different x-intercepts. I'd be hitting -2, +2, and -8.
Wouldn't you also hit 0?
And so that would be, no, I wouldn't hit 0 because of the way that it factored. Not everything had x in it, so I wouldn't hit 0. My y-intercept would be -32. So it'd be the y-intercept would be down here at -32, and that's how I just draw it. I just put a dot there. So now when I actually draw this, it's an odd-based function. So it's probably doing something like this.
So we have to go find it.
And then you're gonna have to find these locations. Now, I don't know if this is exactly the lowest spot. It could turn around before it or after it. And that's what the differential quotient does for us. When you actually when you actually plug into the differential quotient, and you do all the work, and eventually you find out. So if I plug this into this formula, the function of x plus h minus f of x all over h, and you simplify it all the way down for this thing. You plugged in all the x plus h's, and you did that. It should give you a function in the end that you can factor, and it will give you those locations where the peak and valley is. So far, I've been doing the worksheet with you guys as you guys were working yesterday. So far, all of them have been factorable. They worked out nice and pretty. You can figure out exactly where the peaks and valleys are even by factoring it. I still have to finish up, I think, the last one on the last one. But they do work. Now, just remember, you still have to give me a rough sketch of it. X-intercepts, y-intercepts, just kind of draw where the tails go. It doesn't have to be super exact. But then the biggest part of what you're doing on that assignment is you're doing that differential quotient to figure out where the peaks and valleys are. This will take you the most space. You might need to really kind of narrow down what you're doing. Because remember, on this problem, I erased it, but it was like this. 8 minus 4x minus 32. All right, so when we plug this into this function, this is what we have. X plus h cubed plus 8x plus h squared minus 4x plus h minus 32. That is, this part that I just wrote is this thing right here. It takes a while. You have to FOIL that monster out because there's a lot of parentheses here that you have to do. And then in the back, you still have to subtract the original function, right? The original function is this thing. You have to subtract it. This would be the x cubed plus 8x squared minus 4x minus 32. And then this is all over h. Now, here's something that will help you. If you're struggling and you don't know if you're doing it right or foiling, you could type this in Wolfram Alpha and it will tell you what it is. You type in x plus h, put the little cube on it, and it will tell you x cubed plus 3x squared h plus 3h squared x plus h cubed. It'll tell you that if you FOIL it out. That's just that part right there. And then you go to the next part, you FOIL that out, and then after distribute the 8. And you can keep going with that. That's 8x squared plus 16xh's plus 8x, or 8h squared. Then you distribute the -4, and you have the minus 32. All right, so that's just the first part. And then you can keep going on that back. Okay, so now, if you do all this, I'm not even done yet. X cubed minus 8x squared plus 4x plus 32 all over h. All right, eventually, I'm gonna jump you down to the final answer. I think I already know it in my head. Eventually, if I divide everything by h and I plug in zeros for all my h's, the thing will eventually come down to 3x squared plus 16x minus 4. It eventually will come down to that. And you'll have to set this thing equal to 0. Okay? And, hopefully hopefully that's a problem that you can factor apart. If you're not, like, that's why I brought this one up. If you can't factor this apart, let's say you get to this point and you get to this and you're like, God, I don't know how to factor it. Like, I'm not getting that right number. Okay, here's what you can do. Okay, you take this and you plug the numbers in to the quadratic formula like this. So negative b plus or minus b squared minus 4 times a times c, all divided by 2 times a. And this is your x number. You could type that in a calculator and it will tell you the decimal. I want to know the individual coordinates you're getting. So I actually want the decimal. I know that seems tedious. In fact, I'm going to type this in just so you can see it. So, in that parenthesis, or in that radical, I should say, we have 16 times 16 is 256. So 256, 16 times 3, what is that, 48? 16 times
How do you know 256, but you don't know 16 times 3?
All right. So 48 is 3 numbers. I can multiply 2. 3's I have to work on. All right. So that's 304. And then the idea here is that this works out to be the square root of 304. It's plus or minus the negative 16 all divided by 6.
I'm about to do this.
What was that?
Well, I did all this, like all of this.
Yeah.
Yeah, and then I realized stuff down here. The very last, no, but yeah, they were wrong.
Oh no.
That's a rip and a half.
All right. So, because again, the reason I'm doing this is I can't factor. That's why I brought this problem up. So the square
What's
root.
32 divided by 6? Because it's negative 320 divided by 6. I don't know.
Say it again.
32 divided by 6 is 4.
No, that's 8.
Okay.
What? No, 6 times 4 is 24. What do you
Okay. All right. Square root.
I said it. I said it.
304.
Right, 32.
Okay, I gotta delete this. All right. Square root of 304 is 17 point something. I'm gonna add that to a negative 16.
Well, we didn't do that.
And then divide that by 6. So when I take the square root of this, add it to the negative 16, I get like 1 point something. Divide by 6. My first decimal is 0.2392.
Oh, I forgot to do the square root part.
Yeah. And then on the next one, I would subtract the negative 16 plus the square root of 304, which is 17.4355.
We
9,
have a different one.
and divide by 6. So I get same number again. That's pretty wild. Oh, I forgot to put a negative. That's why.
That one.
Yeah, that's why. Yeah. I was like, oh, that's weird. That's the same number. Divide this by 6. All right, we get negative 5.5725. Okay, now those two numbers, I know they're decimals. That's fine. You're going to get decimals on this. You're going to plug those numbers into the original function, and it should give you the peaks and valleys. So this negative 2.23 number should be the one that's way down here by 32. So I can kind of guess where it's at. The negative 5.5 number is right here. It should be up here. It can be taller, but I'm guessing where these coordinates are. Okay? All right. Questions at all? Okay. The rest of the time is yours. You can work on that assignment. I just wanted to go through that in case it wasn't factorable. Everything up till now has been factorable in the end. You can break it up and tell what your 2 roots are really quick. Just, I don't know if yours will be necessarily.
Number 4.
Except for number 4 wasn't? Okay.
Oh, yeah.
I haven't got to that one yet. That's the one I'm on right now, and I'm worried it's gonna be like this.
Yeah.
By just looking at the numbers, I was a little worried.
Yeah, it's just like this.
Okay, perfect. There you go.
Lord, I miss the old Dustin.
Way too long.
Stab me in the back, buddy.
It's okay. The old